Hello. So I would like to talk a little bit about market basket analysis in Python and PySpark, and um, how to do it, in perhaps what I think the most efficient way. So usually, you can do it in your local machine using Docker. You don't have to install Spark because I don't know. I have always lot of issues when installing Spark. There are different algorithms. I think you can find both FPGrowth and Apriori around in Python and PySpark, but FPGrowth is quite efficient. So you have a lot of data. FPGrowth probably is the only real alternative you have. And then we can see a couple of examples. So basically, you want to set up your Docker. You could start running your Visual Studio environment. I created a GitHub repository you can pick up for some of the code and examples, but basically you could just put to run your Docker. So you may need to activate your Docker in the best possible way. If I were to use a normal terminal, I think that would have been easier. So when you put your Docker thing to work, first time could take a little bit of time, but I'm using an image already set up for you to have PySpark, Python, all the versions that you like. So you could, when you have running the server for the, you could go and have a look and all of that. I have it pretty much here, the samples that I wanted to have a look, right? And here you could run them. Both of them you could just run. Yeah, so first time you may need to install, check that the libraries are there. So in this case, you need to install the library mlxtend. So it could take a little bit, but it's a very good, very interesting library in Python, which you can have a number of algorithms or similar. So already done. Let's have a look. Yeah, then you can run all the samples, close terminals. So I have these two notebooks doing basically the same thing, and basically the same silly example that I got from this case. But going back to the README, here you have a little bit of a comparison. Personally, you can use both Python and PySpark. I think in Python usually you could have more algorithms and easier to draw. Years ago, R used to be, really good for this kind of analysis. Probably today is. So for example, Apriori algorithm is not in Spark, but what I think is really interesting of PySpark is the scalability. And I mean, when you're using this kind of algorithm, sometimes you analyze the real data depending on the period of time. Could be really large. So I will go to PySpark. Right. So here you have both of them, both of the notebooks. I put the reference, I put a little bit here because I like to convert the code to .py and all of that, so I can put it in the repository easily. This is an example, it's almost identical. So if you see, these are number of baskets. At the end you need kind of baskets, and each basket have different products, and so on. You go and run the different kind of algorithms just to have a look what is going on there, right? But I think one of the first things that you can see is how the data is organized in working with an a priori algorithm. When you have the baskets, and then you have this kind of matrix, and it's an intermediate product. This is a memory killer. Like this kind of matrix is a very sparse matrix. Yeah, that could be really not the best for in terms of memory, and but still, could be very efficient. Here is kind of the a priori output, which is definitely very common and very used. Probably there are many potential kind of videos around explaining with more detail. Here is just to convert the notebook into code, and I can put in the GitHub repository. A similar thing with Spark, you just need to set up your Spark session. Remember, I mean, this is a very simple session, but usually you may need to include here other information for the cluster or server, Kubernetes or whatever, but you could easily distribute this. In here, we are going to have an issue with particularly this onion. So it's like two elements, two times the same element. That is a killer for FPGrowth algorithm. So also in general, Spark uh, have a slightly different kind of data input and output. So basically I have to remove that onion, left just one. You could put onion 2, onion 1, onion 2, something like that. But the key idea is you need another format. Here I just put it in another format following an example, and apply FPGrowth, and I also just load the outputs for this kind of algorithm, right? And so place them there. They are created so you can have a look with more detail. But basically, so I place some references here. So basically here you could see a little bit about the code. Here it gives you a little bit more of the context, frequent pattern mining, and a couple of algorithms, and it tells you a little bit the ideas and what is going on with the key kind of options in the functions, right? So always very interesting. I think in the mlxtend you will have like kind of comparisons. It's a very good documentation. Let me open that for you as well. So, oh, sorry. So here you have FPGrowth, a little bit of an example. So they use FPGrowth, but they parse the data in this way as well. So basically, it's going to avoid the error you may have with Spark here, in which you have two elements the same, by using this table where the amount of things are not reflected. And here you have your output, and there's a comparison in terms of time between a priori and versus FPGrowth algorithm. The key thing is they make here a kind of comparable scenario, and you can see FPGrowth is 3 times faster. So always interesting, just to have a look and being able to see that. In general, a priori has been the classical. People use it a lot, or similar. So mention here is a kind of an output, and here you see apples, right? What would be the association with apple? Well, basically, apples only appear in one basket, so they support it all with the same thing, right? Now you have other products where it appears with more than one. Uh, that would be more interesting, right? Like corn. You can see corn and kidney beans appear in two baskets, right? We can go and see that in the real data. A really small little sample that we have. You have here your corn. Corn, it appears in two baskets, right? We could select kidney beans appear everywhere. Unicorn appeared only in one basket. So in there you have a little bit more like to start interpreting what is you are doing the market basket analysis, right? So if we were recommending products, I will go with kidney beans because basically kidney beans is all around look like a product that is appearing quite a lot. Then if you go corn, kidney beans, here are the possible next steps, and you could add other product or other recommendation. Basically, the next recommendation could be something like X, could be something alike. Uh, there are other options. You could add other products, but there are not really many cases, so I don't want to bother you with a long discussion. But I think hopefully you can see the idea of a tree and how you could start recommending other products or similar. Keep in mind that this algorithm was not created thinking in baskets, but it's a very similar problem.